Hello, this is the Intro to Physics. This is by me, and I created the slides, and I have a camera in the background. Okay, so basically, this Intro to Physics is, okay, this is just a little intro. So we're going to be learning about Newton's three laws, and to help you guys fully understand them, we have some things over there, like some Hot Wheels, and I would like to take you guys, if you guys want to ask any questions about me, or know anything, because my name is Lucas Salgado, and I'm a sophomore at Cajon High School. Is there anything you guys like to know?
Why would you choose
This
the physics? Yeah.
Well, because I've always been a passion of mine, and the whole goal about this is to teach you guys and to give you guys an idea and a career to physics. Because this is a very good career. It is still an ongoing study because, as you may know, physics goes into a very big, deep subjects, such as even going into space and all that. It's a big thing. There's a lot to it, and this is just a little intro to it. It's a little tidbit of what we have. And this is basically a basic understanding. All right. So, this is Newton's first law. An object in motion will stay in motion unless acted on by an internal force. So, if you look in the little corner of the giraffe, it keeps on going until it hits the wall and then he stops. That's kind of what the whole point of this is. If you can always go as far as you can, things will never stop, but there's always an external force to stop it. So, here's the Hot Wheels thing. So, if you had it at a table, one of you guys can look at over there. So, if you roll a Hot Wheel, see, exactly like that. You roll a Hot Wheel, and if you put your hand in front of it, it stops. It'll always happen, no matter what you do. If you move something, as long as it's powerful enough and weighs more to stop it, it's gonna stop it. Yeah, just try sliding. See, it's always gonna stop. That's just basic first one. So, how do you think it works? Do you guys have any questions how it works? Anything you guys want to talk about?
How does the gravity?
The gravity actually does affect it. That's one of the external forces. That's one of the reasons why it slows down.
Wouldn't the push be a force?
The push would be a force, making it go into motion. So, is there anything else?
So why does it stop rolling?
Why does it stop rolling? Because there's mass in front of it. When you have an object in front of it, the object, that's the external force.
But if you roll it by itself,
It's going to stop rolling because another external force is the friction from the table. There's a lot of things to it. See? That makes sense. Alright, let's move to the next slide. So, that's basically, I just gave you guys a basic explanation of how it is. The heavier the head is, the quicker it's going to stop. See, it rolls down because of friction. So, basically, that's what the entire first law of motion is. Can we go to the next slide? Any questions about this? Because there's obviously a lot of this, because over there, air force, friction, and drag, there's a lot of things. If you throw a baseball, the reason it slows down is because of the drag from the air.
Yeah.
There's
It slows
air
it down.
resistance. Air resistance slows it down. That's the external force causing it to stop. Any questions about this? No?
No,
You
it's
explained it very well.
Alright, next slide. Okay, so Newton's second law. This one's a bit harder. Force times mass, or force equals mass times acceleration. F equals ma. Let's move to the next slide. This one's gonna be a lot. So this is a lot to think about, but the amount of force produced, it will always equal the amount of mass that the object takes. The mass the object is and the acceleration it takes. So next slide. This is a lot. So when you look at the Hot Wheel you have, it is a very small object. Its mass is very small. But the acceleration will go really high, which causes a lot of force. But you really need a lot of mass and a lot of acceleration in order to provide a lot of force. That's why if you look at airplanes, you would think if it crashed, it'd create a lot of force because its mass is so heavy and the acceleration goes so fast. It causes a lot of damage. So basically, the amount of speed it has and the amount of heavy it is, that's how much force it's going to pack. It's going to pack a big punch if it crashes into something. That's the force. So basically, yeah. The bigger and faster it goes, the amount of force it can produce, and the force isn't like an X. What is like that? You can punch something, and as heavy as head is and how fast it's going will equal the force. Obviously, there's other factors to contribute, but this is basically what it is. Next slide. Okay, so here's an example. Right here. If it's 8 kilograms big, and it's going at 25 meters per second, the amount of force it's going to produce is 200 newtons. Newtons is a measurement of force for science. So if you look at newtons, that's a measurement of force. That's yeah, basically what it is. It's called Newton's because Newton founded all this. Okay, so I gave you guys the answer already, but I wasn't supposed to. Okay, well we'll skip that because I have questions at the end. Okay, next slide. So you guys understand this. So here's Newton's third law. When an object acts on another object, equal and opposite forces apply. Now this is a really big, weird one to understand.
Wait, so is it when you punch the wall?
The wall will come back and hurt you. That's exactly what it is. Alright, so to further explain it, next slide please. We're gonna look at this. Like it sounds, okay, so grab your Hot Wheel and flick it. Just flick it. On the table. So, yeah, like that would work, but you can also flick it on the table. Well, depending on how hard you flick it, the more it's going to hurt your hand, which is basically what I'm trying to say here. So, next slide. As it stands, yeah. So, basically, the amount of force you produce on the object, it's going to produce right back with equal and opposite force. So, if you flick it really hard, it's going to hurt your hand back with the equal amount of force, and it's going to go opposite way, basically. So, it's equal and opposite force.
Yeah.
Equal and opposite reaction. Next slide. If you have any questions, try and talk around and see what you guys can understand about this, because this one's one of the hardest ones other than the second law. Would you guys have any questions about anything? Do you need any more examples?
How's the Clayton one work?
How's it what?
The Clayton one.
The equation one, wait. What do you not
How'd you get
understand?
how'd you get 200?
So 8 times 25 equals 200.
Okay, that makes sense.
So yeah, that's why it equals that. No matter what, if you just multiply the amount of mass it is and the amount of acceleration it has, it'll always equal the amount of newtons it can produce. Any questions about the third law and how it works?
What about a bouncy ball?
Or bouncy ball? Bouncy ball, good question. When you bounce it onto the floor provides an equal and opposite reaction. So the equal reaction brings it up. So that if you throw it harder, it's going to go higher up, right? And the opposite reaction is it going up instead of just going anywhere else. It goes up depending on where you throw it at. If you throw it at an angle, the equal reaction would be the amount of force applied. The opposite would be where it goes.
So if you softly throw the rubber ball,
It's
on the
going
floor,
to
it's gonna
bounce
be-
with a way smaller thing because it's giving about equal force back.
okay.
So anything else you're confused about? 'Cause
So every
even
object has its own mass, right?
object has its own mass.
So the newtons would be higher.
The newtons would be higher.
depending-
Yes.
Wait, so the bigger the mass,
And the faster it goes, the more amount of force. If you can correlate this to walking, let's see if I have a next slide. So, yeah, basically what I'm saying. The more harder you flick it, the more it's going to hurt you back, but the more farther it goes. That's why the harder you do things, the more it hurts, but the better it is. It's kind of like that. Walking also relates to that, because, well, I believe I have so next slide. Okay, so, this side you're just trying to move a wall. You have a wall right here, but you can't move it. And it's obviously way heavier and it's grounded, but let's say the wall isn't moved, isn't locked in. Let's say it's just a wall there that you can push over. The reason you still can't push over a wall, unless you're really strong, of course, is because you're applying equal force, the wall's applying equal force back to you. And unless you're able to exhibit more force than the wall's able to withstand, you'll never be able to push it over. It's operating an equal force right here, and the opposite reaction is pushing me back instead, because this is heavier. That's how you're able to move a Hot Wheel, but you can't move off a wall, because the wall can provide an equal force than what you can. It's bigger and heavier, so the mass just does that. Okay, so, next slide. Now you might see how these work. Well, we have questions on the next slide, so, when you guys are ready, can anyone give me an example of what is inertia? Because inertia is a big fancy way of saying something else. So, anyone have an idea of what inertia is?
Inertia isn't it like speed?
Inertia is close to speed, but it's not. What is it? No, that's not it. Does anyone know what inertia is?
isn't it when a
No.
force is still moving, like after it's been?
No, but it has to do with object moving. Inertia is a fancy way. It's a coin term of calling the first law of motion. First law of motion: an object stays in motion unless acted by an outside force. Is inertia. That is what they call inertia. And now, can you guys give me an example of inertia, which is the first law of motion? An example of something moving until it is acted by an outside force.
Oh, what was it? Hot Wheel.
The Hot Wheel, but any other examples? Because I gave you that one for free.
When you push a ball.
When you push a ball. Yes, that works. When you push a
Oh,
ball,
when you
it'll
kick a
always slow
ball.
down.
When you push a car down. Yeah.
When you push a car downhill, yeah, that works. It keeps on adding extra force because of downhill motion, and then eventually goes to a stop because it's going to either crash or slow down. That is a great example. You want candies now or later?
Wait.
Later. Fair enough. Okay, so what is Newton's third law of motion?
you have twists.
I don't know. What is Newton's third law of motion? Does anyone know?
What's the? No, you just told us.
Yeah, I just told you. That's why I had it back there. Just kidding. So you know.
Newton.
Newton. No. Mom, you know?
Well, kind of like when they put resistance, that it's up to.
Resistance and it's equal to relative force.
force,
Yeah.
Oh,
Yeah, that's what it is. I'm gonna give it to Mom for that one. Okay, so basically that's third law. Newton's third law is when an object is when you apply force on an object, the object gives equal and opposite force back. Can you give me an example of the third law other than walking in the hot wheel and pushing moving wall?
Obviously, like punch a punching bag.
When you
Hey,
jump,
that's good. No, punching a punching bag is a perfect example of that. The reason it hurts so much is because the punching bag weighs so much, and the amount of force you apply into it, because the amount of force you have is the mass and acceleration. But since it has a much more heavier mass, it hurts, and you're pushed back every single time. That's exactly good. Does anyone else want to give an example? He's gonna hand it off.
when you're jumping,
When you're jumping is because you're pushing off the floor, and well, it's also an example of every single law happens at every moment. You can look at one moment, one thing, and you can see every single law applied there.
oh yeah, that's why you can't jump super high because the air resistance.
Because also air resistance. Also, gravity is a big factor in a lot of this. But if you factor out gravity, things can move on forever. So it's not really fair. So what could be the kilograms used when the meters per second is 5 and the amount of newtons produced is 125? Now, what this is saying is basically we have an equation. So we know the amount of force totally produced is 125 newtons. But the acceleration we know that there is 5 meters per second. So if you guys understand that force equals mass times acceleration, and we have the force and we have the acceleration, what is the mass? 25. You got it. 5 times 25 equals 125. So that means the mass of the object is 25 kilograms. You got it right there. That was a big one. Okay, come up with a good question. And no math because we don't have a calculator, but come with a good question on someone else. So you can ask anyone a question about what we just learned. About Newton's laws and all that. Ask anyone a question. It's not a question. Okay. What type of question do you guys have? To ask any of the classmates you have. If you guys remember anything specific, ask them and see if they remember. It'll be a good thing to just for that.
What is the first law of Newton?
The first law of motion. It is Newton's law. Yeah.
Punch a person, is there resistance?
It is what?
If I punch a person, is there resistance?
That is not the first law, no.
Oh, the first law?
If there's a wall in front of a car, it would crash into the wall, right?
No,
The person will still be
that
moving,
just
right?
happens if it's a drunk driver or something. So the first law of motion is just an object stays in motion until it's acted on by external force or inertia, you can call it.
Inertia.
Yeah, so an object will always move, continue moving, unless it's acted on by an outside force. You can never see anything, you can always move no matter what, because there's so many things to it. Now, if you guys have a question about that, I can answer that. So you guys basically answered all the questions. There's no more questions for the bonus? The bonus, no one has anything? Okay, let's move on to the next slide. And here's any last questions. Now, in order to ask any last questions, we can do this. We can do that actually. Do you guys have any last questions about how things always work like that? Like how do things always have to stop no matter what?
Well, you say that everything has some kind of thing, right?
It's, everything has an external force.
This stops when you push it because of friction.
Friction and air resistance.
So is there something that doesn't cause it to continue moving without any friction or anything stopping
That
it?
is a good question. The problem is that something will always stop it, no matter what. A perpetual motion machine, which is what you're trying to talk about, something that can always move without any problems, does not exist. It is a completely different reason, because a lot of, I believe, thermodynamics, it always stops. No matter what, there's no such thing. Because you will always lose power, and the power is that always going to be that external force that helps push it with its force. But because it slows down, all the external forces that could come, like air resistance, drag, even gravity in space will always slow something down. Even though it will move forever, it's always going to crash, no matter what. So even crashing, yeah. Yes, that's a good question.
How come airplanes in the sky?
Because they can actually provide enough force for them to cut through the air, and the turbines, really strong, they just keep on flying. They have to stop at some point because they can't infinitely fly through the air, and they also have to have those wings to cut through, because if not, air resistance will just drag them down.
I'm over real. I thought physics was fake. But now I know physics is real. I thought, cause I was like, how do airplanes stay in the sky? There's no way.
There's no way.
It's a bird stay in the sky.
Yeah, birds stay in the sky because they're able to provide enough force to, fly through the air. And also gravity is a big factor. Gravity is the reason why these were made. If you guys know, Newton had, well, it's known that an apple fell on Newton's head, and he wondered, how did that happen? How did an apple fall down on his head? That is when he discovered gravity. And he made 3 laws about it. And these are the 3 laws I showed you. These are the 3 laws of gravity, basically. We call it the 3 laws of motion because gravity always keeps things in motion until they're on the floor. Well, it always keeps things in motion. If you put like an object still on the floor, slide it, it'll fall down because of gravity. And this is how gravity works, basically. Any other questions on how this works? No? Okay. Next slide. And here's the last slide. Thank you for participating, and I hope you guys have a good weekend. That's me and my friend Gio. I finished this in class with them, and he was there. So I decided to celebrate, and here are 3 dogs, just because I like my dogs.
Why is the dog all the way top right so ugly?
This one? Yeah, I agree.
Why was the dog in the top right about to jump the other dog?
This one was trying to run away. I don't even know why. That's a straight menace. For real.
No, why was the top right dog about to attack this dog? This thingy.
I don't know, honestly. Anyways, thank you for participating. I hope you guys have a good time. We'll get the forums questions answered, and then after that, you guys are good to go. If there's any last questions, you can ask me after. If you guys are interested about anything else, you guys can ask me. I know a little bit about physics, more so than, you guys, but you guys have any questions? Yeah, we're good. Thank you very much, and I'll see you guys later. We're good.